10.4, graphing quadratic functions using the vertex practice. These are your solutions. So the first 7 through 12, we are going to be graphing these, telling the axis of symmetry, the vertex, the y-intercept, if this has a maximum or minimum, the value of that, and the domain and range, and as well as graphing. So for 7, we have f of x is equal to x squared minus 5. If we want to identify our a, our b, our c, our a is 1, our b is 0, because there's no x value there, and then our c is negative 5. So our axis of symmetry is x is equal to negative b over 2 times a. So this is going to be 0 over 2 times 1, which is just x is equal to 0. If we plug that in, we get what y is equal to. So then we would have y is equal to 0 squared minus 5. So y is equal to negative 5. So that vertex is 0, negative 5. Our y-intercept is also 0, negative 5. So we can graph this first point here, and then we can look at our next value, our maximum or minimum. Well, this x squared is a positive a, so we have a minimum, because it'll open up, and that minimum value is the y value in our vertex, so that's negative 5. Our domain, just like any other quadratic function, is all real numbers, and our range is y is greater than or equal to negative 5. So to find two other points on the left or on the right, we're going to find values of x that we haven't used yet. We haven't used 1, so we can plug 1 in for this to get y is equal to 1 squared minus 5. So y is equal to 1 minus 5. Y is negative 4. So that's 1, negative 4. So we can plot that point and then mirror it on the other side of that vertex. We can also use 2, so y is equal to 2 squared minus 5. Y is equal to 4 minus 5, so y is negative 1. So that's 2, negative 1, as well as negative 2, negative 1. From here, we just draw the line through our points, making sure we have arrows on both sides of the line, and then we're done. For number 8, we are given g of x is equal to x squared plus 4. So our axis of symmetry is going to be 0 again, because there's no b. Our vertex is 4, or 0, 4, which is also our y-intercept. So we're going to plot that. We have a minimum value here because our a is positive, and that minimum value is 4. Your domain is all real numbers. Your range is y is greater than or equal to 4. So we haven't used 1 as an x value or 2, so I'm going to use both of those. So when x is 1, we're going to have y is equal to 1 squared plus 4. So it's 1 plus 4, which is 5. So that's the order pair 1, 5, which is going to be here. We're going to mirror that on the other side of our vertex, and then work with 2. So that's y is equal to 2 squared plus 4. So y is equal to 4 plus 4, which is 8. So that's the ordered pair 2, 8. So again, we're going to just mirror that onto the other side of our vertex, and then draw the line through the points. For 9, we're given h of x is equal to x squared minus x minus 6. So for this one, our a is 1, our b is negative 1, and our c is negative 6. So when we find that axis of symmetry, we're going to have x is equal to a negative times negative 1 over 2 times 1. So that's just 1 over 2. So x is equal to 1/2. Find your vertex by plugging in the 1/2 in for x and simplifying. So y is equal to 1/2 squared minus 1/2 minus 6. The 1/2 squared is 1/4. The 1 over 2 is also 2 over 4, and this is negative. And that 6 is 6 over 1, which is 24 over 4. So we have 1 minus 2, which is negative 1 over 4, minus 24 over 4. So that's negative 25 over 4. So this vertex is going to be 1/2, comma, negative 6 and 1/4. So we can plot that point, 1/2, negative 6 and 1/4. It's going to be about here. From there, our y-intercept is that value of negative 6. So that's 0, negative 6. We can plot that point as well. So that's going to be these 2 points. We have a minimum value because a is positive. That minimum value is negative 6 and 1/4. We have our domain of all real numbers, and our range is y is greater than or equal to negative 6 and 1/4. Pick x values. We have 2, we have 3 that we can work with. So when x is 2, we're going to have y is equal to 2 squared minus 2 minus 6. So y is equal to 4 minus 2 minus 6. 4 minus 2 is 2, minus 6 is negative 4. So it's 2, negative 4. We're going to mirror that on the other side. And then we're going to also try 3. So we're going to have y is equal to 3 squared minus 3 minus 6. 3 squared is 9, minus 3 is 6, minus 6 is 0. So that's going to be 3, 0. So again, we're going to mirror that onto the other side of our vertex. This should be, these are wrong. This is wrong, this is wrong. So because there's 1 from between these two, there's going to be 1 between these two. So this is going to be negative 1, negative 4, and then 1 over up to 0, so negative 2, 0. There we go. That looks better. So draw our line through these points, and we have our parabola. For number 10, we're given t of x is equal to 4 minus x squared plus 5x squared. 4 minus 10x plus 5x squared. So our a is the 5, our b is the negative 10, and our c is 4. So to find our axis of symmetry, do negative b over 2 times a. So that's going to be positive 10 over 2 times 5, which is 10 over 10, and that's just 1. So x is equal to 1. Our vertex, plug it in. So we have 4 minus 10 plus 5 times 1 squared, which is just 5. So 4 minus 10 is negative 6, plus 5 is negative 1. So that's 1, negative 1. We can plot that first point. Then our x-axis is the positive 4. Our y-axis is the positive 4. So it's 0, 4. We are going to mirror this point as well. And then we have a minimum value. Our minimum value is the negative 1. We have a domain of all real numbers, and our range is y is greater than or equal to negative 1. Now, we didn't use 3 here, so we can use that, or we can use negative 1. I want to use negative 1 just because it's a smaller number. So I'm going to have 4 minus 10 times negative 1 plus 5 times negative 1 squared. So this is going to be 4 plus 10 plus 5. 4 plus 10 is 14, plus 5 is 19. That's not going to fit on our coordinate plane, so I'm just going to use these 3 points to draw my parabola. For 10, we have g of x is equal to 9x squared minus 4. So for this one, our a is 1, our a is 9, our b is 0, and our c is negative 4. So because our b is 0, our axis of symmetry is x is equal to 0. Our vertex, we plug the 0 in, we're going to get 0, negative 4. That is also our y-intercept. So we're going to plot that point. And then we have a minimum value which is negative 4. Our domain is all real numbers, and our range is y is greater than or equal to negative 4. We're going to plug in values here, so we're going to try 1. So this is going to be 9 times 1 squared minus 4. That's going to give us 9 minus 4, which is 5. So that's 1, 5. Which we're also going to get negative 1, 5. You'll see that this is very narrow. So when we plug in 2 there, we would have 9 times 4 minus 4, and that's not going to fit on our coordinate plane. So we are just going to draw the line through these points and get our parabola that way. For number 12, we have f of x is equal to 1/4 x squared. So with this one, we just have an a of the 1/4. Our b is 0, so our axis of symmetry is going to be x is equal to 0. We plug that in, we get 1/4 times 0, which is 0. So our vertex is 0, 0, which is also our y-intercept. So we're going to plot that point, 0, 0. Our maximum or minimum, this is a minimum because our a is positive and that minimum is 0. Our domain is all real numbers, and our range is y is greater than or equal to 0. We're going to plug in values here. If we plug in 1, we're going to get a fraction for our y value, and I don't want a fraction. So I'm going to plug in 4 or even 2. If I plugged in 2, I'm going to have y is equal to 1/4 times 2 squared, which is 1/4 times 4, and that's just 1, so that's 2, 1. It's also going to give us the ordered pair negative 2, 1. So if I use 4 as well, I'm going to have y is equal to 1/4 times 4 squared, which is 1/4 times 16, which is 4. So that's 4, 4. So now that I have these points, I can draw my parabola through them. And then I'm done. So the next questions, 13 through 24, I think it was, we are going to be identifying the axis of symmetry, the vertex, and if there is a maximum or minimum and what that value is. So for 13, they give us g of x is equal to negative x minus 3x. So our a is negative 1, our b is negative 3. So our axis of symmetry, x is equal to negative b over 2 times a. We're going to have x is equal to a negative times negative 3 over 2 times negative 1. So these are going to become positive. This is going to stay negative, so x is equal to 3 over negative 2, which is negative 3 over 2. If we plug that in for x, we're going to have y is equal to negative 3 over 2 squared minus 3 times negative 3 over 2. So the negative 3 over 2 squared is a positive 9 over 4. It's still going to be negative, though, because that negative is out front. The negative 3 times negative 3 over 2 is positive 9 over 2. So this is going to be y is equal to negative 9 over 4 plus 18 over 4. So we're going to simplify this to give us y is equal to positive 9/4. So our vertex is the ordered pair, negative 3 over 2, comma 9/4. And for this one, because our a is negative, we're going to have a maximum value. And that maximum value comes from the y value in our vertex, which is at 9/4, which is also 2 1/4. So we have our maximum value, the vertex, and the axis of symmetry of x is equal to negative 3 over 2. For 14, we have f of x is equal to 4x minus x squared. So our a is negative 1, and our b is 4. So we are going to have x is equal to a negative times negative 1 all over 2. Oops, a negative 4. Let's do it this way. X is equal to negative 4 over 2 times negative 1. There we go. So we're going to simplify this. X is equal to 4 over 2, which is x is equal to 2. Our vertex, we're going to plug that in, so we're going to have y is equal to 4 times 2 minus 2 squared. So 4 times 2 is 8, 2 squared is 4, 8 minus 4 is 4. So that gives us the ordered pair 2, 4. To find our maximum or minimum, our a is negative 1, so that means that we're going to have a maximum value, and that value is the 4. So our maximum, we have 4, our vertex is 2, 4, and our axis of symmetry is x is equal to 2. For 15, we have h of x is equal to negative x squared minus 8x minus 15. So for this one, our a is negative 1, our b is negative 8, and our c is negative 15. So we are going to have an axis of symmetry of x is equal to a negative times negative 8 all over 2 times negative 1. So a negative times a negative is a positive, so it's going to be 8 over negative 2, which is negative 4. For our vertex, we're going to have y is equal to a negative times negative 4 squared minus 8 times negative 4 minus 15. Oops. So this is going to be y is equal to negative 16 plus 32 minus 15. So the negative 16 plus 32 is positive 16 minus 15 is 1. So this is going to give us a vertex of negative 4, 1. And then that a is negative, so we're going to have a maximum value at 1. For 16, they give us k of x is equal to 1 minus 3x minus 6x squared. So our a is negative 6, our b is negative 3, and our c is 1. So this is going to give us an axis of symmetry of x is equal to a negative times negative 3 over 2 times negative 6. So this is going to be 3 over negative 12. Which is negative 1 over 4. For our vertex, we have y is equal to 1 minus 3 times negative 1, positive 1/4. Oops, the eraser. Alright, so positive 1/4 minus 6 times 1/4 squared. So y is equal to 1 minus 3/4, which is, minus 6 times 1 over 16. So this negative 6 over 16 is going to simplify to be 1 over 8, 3 over 8, negative 3 over 8. So we're going to have y is equal to 8 over 8 minus 6 over 8 minus 3 over 8. Alright, so 8 minus 6 is 2, minus 3 is negative 1. So y is equal to negative 1 over 8. We're going to have the ordered pair for our vertex 1/4, negative 1/8. And then because our a is that negative 6, we have a maximum value, and that is the negative 1/8. For 17, we're given f of x is equal to x minus 2x. So for this one, our a is negative 2, our b is 1, and our c is 0. So this is going to give us x is equal to a negative 1 over 2 times negative 2. So that's 1 over 4. To get our vertex, we're going to plug that in, solve for y. So y is equal to 1/4 minus 2 times 1/4 squared. So that's 1/4 minus 2 times 1 over 16. 1/4 or 4 over 16 minus 2 over 16. 4 minus 2 is 2. So that's going to be 1/8. So that's 1/4, 1/8. We have a maximum value at 1/8. For 18, we are given h of x is equal to 1 minus 1/3 x squared. So our a is negative 1, our b is 0, and our c is 1. So our x is equal to 0. Our vertex, we're going to plug that in and just get 0, 1. And then we have a maximum value at 1. And again, I'm doing this because my x is 0. So I can go ahead and just plug that in, and my c value is going to be my y and my vertex, and the x is just going to be 0. For 19, we have 2x squared, so our a is just 2, our b is 0, and our c is 0. So our axis of symmetry is going to be x is equal to 0. Our vertex is just going to be 0, 0. And we're going to have a minimum value, because a is positive, at 0. For 20, we have y is equal to 3 minus x squared, so our a is negative 1, our b is 0, and our c is 3. So x is equal to 0, our vertex is going to be 0, 3, and then we have a maximum value, because a is positive, at 3. For 21, we have 3x squared. So again, we have a b of 0, so our axis of symmetry is x is equal to 0. Our vertex, if we plug that in, we're just going to get 0, so that's 0, 0. And then we have a minimum value at 0. For 22, we have negative 3x squared, so same thing. We have x is equal to 0 for our axis of symmetry. Our vertex is 0, 0. Except this one has a maximum value because a is negative at 0. And then 23 and 24 are the same way. So we have zeros for our b value. So our axis of symmetry is going to be x is equal to 0. Our vertex is 0, 0. And then for 23, we have a minimum value because a is positive at 0. And then 24, we just have a maximum value at 0 since a is negative. For our next example, we have y is equal to x squared minus 4x. So our a is 1, our b is negative 4, and our c is 0. So we know automatically we're having a y-intercept is 0, 0. We can plot that point if we'd like to. To find our axis of symmetry, we're going to have x is equal to negative b over 2 times a. So that's going to be x is equal to negative times negative 4 over 2 times 1. So it's going to be a positive 4 over 2, so that's just x is equal to 2. We plug that in, we get y is equal to 2 squared minus 4 times 2. So that's 4 minus 8, which is negative 4. So that's the ordered pair 2, negative 4. I'll plot that as well. So I haven't used 1 or 3. That 4 is going to be 4, 0. So I'm going to plug in the 1 to find out my y value, and I'm going to have y is equal to 1 squared minus 4 times 1. So it's 1 minus 4, which is negative 3. So 1, negative 3. So my parabola is going to look like this. I have a minimum value here at the negative 4. My domain is all real numbers, and my range is y is greater than or equal to negative 4. For 26, we have y is equal to negative x squared plus 2x. So our a is negative 1, our b is 2. To find our axis of symmetry, we're going to have x is equal to a negative 2 over 2 times negative 1, which is just negative 2 over negative 2, which is 1. So x is equal to 1. We're going to plug that in and solve for y. So y is equal to a negative times 1 squared plus 2 times 1. This is going to be negative 1 plus 2, which it gives us a y of 1. So that's negative 1, 1. Sorry, it's 1, 1, not negative 1. Our x is 1, our y is 1. We're going to plot that point. Our y-intercept is 0, 0. So we know we're also going to have 2, 0 as an ordered pair. We can plug in negative 1 or 3 to get what y is for those x values. If we did negative 1, we're going to have negative times negative 1 squared plus 2 times negative 1. So this is going to be negative 1 minus 2, which is negative 3. So negative 1, negative 3, and 3, negative 3 are going to be ordered pairs. Draw the line. We have our parabola. For this one, we have a maximum value at 1. Our domain is all real numbers, and our range is y is less than or equal to 1. That y-intercept, since c was 0, is just 0, 0. For 27, we have y is equal to negative x squared minus 5x plus 6. So our a is negative 1, our b is negative 5, and our c is 6. So x is equal to negative b, so that's a positive 5, over 2 times negative 1, which is negative 2. It's negative 5 over 2. X is equal to negative 5 over 2, which is the same thing as negative 2 and 1/2. For our vertex, we have y is equal to a negative times negative 5 over 2 squared minus 5 times negative 5 over 2 plus 6. So that's going to give us y is equal to negative 25 over 4 plus 25 over 2 plus 6 over 1. So y is equal to negative 25 over 4 plus 50 over 4 plus 24 over 4. So the negative 25 plus 50 is positive 25, plus 24 is going to give us 49 over 4. So this is 12 and 1/4. So our vertex is negative 2 and 1/2, comma 12 and 1/4. We can plot that. Negative 2, 12 and 1/4 is going to be about, other way, on the top, not the bottom, positive. That's going to be about here. Our y-intercept is 6, so that's going to give us this point here. We have a maximum value since a is negative. That maximum value is the 12 and 1/4. Our domain is all real numbers, and our range is y is less than or equal to 12 and 1/4. So this is also going to give us the ordered pair of, since it was 0, we're going to have negative 2, 6, and our line, oops, how did this work? 2.5, not 1. Okay, let's redo this. So this is getting both. Alright, so 2 1/2, 12 1/4 is here. So we're going over half, 1, 2.5. So we're going to go to the left 2.5 and go down to 6 and plot that point. So we have these 3 points. We can actually draw our parabola through those 3 points and a pretty good idea on what this looks like. For 28, we're given y is equal to x squared minus 3x minus 10. So our a is 1, our b is negative 3, and our c is negative 10. So x is equal to negative times negative 3, which is positive 3 over 2 times 1. So it's 3 over 2, or 1 1/2. To find y, we're going to plug that in. So 3 over 2 squared minus 3 times 3 over 2 minus 10. 3 over 2 squared is 9 over 4. The negative 3 times 3 over 2 is negative 9 over 2 minus 10 over 1. We all have a like denominator here. That's going to be 4. So this is 9/4 minus 18 over 4 minus 40 over 4. Then 9 minus 18 is negative 9. Negative 9 minus 40 is negative 49 over 4. So this one is negative 12 1/4. So this is going to be our vertex of 1 1/2, comma negative 12 1/4. So from here, we have a y-intercept of negative 10. So it's 0, negative 10. That went over 1 1/2, so we're going to do the same thing on the other side. And we're going to have the ordered pair 3, negative 10. Let's use negative 1 to find that value. So negative 1 in there for x. We're going to have y is equal to negative 1 squared minus 3 times negative 1 minus 10. So negative 1 squared is 1 plus 3 minus 10 is 4 minus 10, which is negative 6. So it's negative 1, negative 6. We're going to mirror that onto the other side and get 4, negative 6. So we're going to draw our line through these points. And then we have our parabola. We do have a minimum value at negative 12 1/4. Our domain is all real numbers, and our range is y is greater than or equal to negative 12 1/4. For 29, we have y is equal to 4 minus 1/3 x, so our a is negative 1/3. Our b is 0, which means our axis of symmetry is x is equal to 0, and our c is 4. Our vertex is going to be 0, 4, which is also our y-intercept. We have a maximum value because a is negative. That maximum value is at 4. We have a domain of all real numbers, and a range of y is less than or equal to 4. So you got to pick values here. I would pick values that are going to cancel out that fraction. So I'm going to pick 3 for an x value. So I'd have y is equal to 4 minus 1/3 times 3 squared, which is 1/3 times 9. So that's going to give us 4 minus 3, which is 1. So 3, 1. I went over 3 and down to 1, so it's going to be negative 3, 1 as well. I'm also going to use 6. So when x is 6, we have y is equal to 4 minus 1/3 times 6 squared. So that's 36 divided by 3, which is negative 12. 4 minus 12 is negative 8. So that's 6, negative 8, and negative 6, negative 8. So to draw my line through my points, my problem is going to look like this, and then I'm done. For 30, we have 6 plus 6x minus 1/3 x squared. So our a is the negative 1/3, our b is the 6, and our c is the 6. So our axis of symmetry is negative 6 over 2 times negative 1/3. This is going to give us a negative 6 over negative 2/3. So negative divided by negative is a positive. So that's going to be 6 divided by 2/3, which is the same thing as 6 times 3 over 2. 2 becomes a 1, 6 becomes a 3. So it's 3 times 2, which is 9. So x is equal to 9. We're going to plug that in. We get y is equal to 6 plus 6 times 9 minus 1/3 times 9 squared. The 6 times 9 is 54. The 1/3 times 9 squared is 1/3 times 81. Now, if we divide the 81 by negative 3, we get a negative 27. So that is 6 plus 54 minus 27. 6 plus 54 minus 27 gives us 33. So that is way too big, but we still have to give our vertex, which is 9, 33. Our y-intercept is 0, 6, so we can at least plot that point. And then we have a maximum value, because that negative 1/3, our maximum value is the 33. Our domain is all real numbers, and our range is y is less than or equal to 33. Now, you can choose points from here to plot this. If you did, let's say, negative 1, you can do 6 plus 6 times negative 1 minus 1/3 times negative 1. Now, I wouldn't do this. I would have used 3, because I know that 3, so let's do negative 3, is going to get rid of that fraction for me. So 6 plus, negative 18 plus, nope, that's negative 2. 3. 6 minus 18 is negative 12 minus 3 is negative 15, which is not going to be on our coordinate plane anyways. So this we know is going to go up, and it's going to go up very steep, so we're going to leave it just like that and be done. Okay. So for our next one, we have f of x is equal to x squared minus 6x plus 8. So this is going to give us an a of 1, a b of negative 6, and a c of 8. So x is equal to 6 over 2, which is 3. We plug that in to get y. That's going to give us 3 squared minus 18 plus 8, which is 9 minus 18 plus 8. 9 minus 18 is negative 8. 9 plus 8 is negative 1. So that's 3, negative 1. We also have a y-intercept of 8. Which is going to give us 6, 8 as well. We have a minimum here at negative 1. Our domain is all real numbers, and our range is y is greater than or equal to negative 1. You could just take these points and draw your line through them. To get more precise points, we could use 1 or 2 to find those points in between. Same thing with 4 or 5 as well. For 38, we have f of x is equal to x squared minus 8x plus 15. So we have an a of 1, a b of negative 8, and a c of 15. So x is equal to negative times a negative 8 is 8 over 2 times 1, which is 2, so that's 4. For y is equal to 4 squared minus 32 plus 15, that's 16 minus 32 plus 15. So 16 minus 32 is negative 16 plus 15 is negative 1. So that's 4 negative 1. We have a y-intercept of 15, which does not fit on our coordinate plane. We have a minimum value at negative 1. Our domain is all real numbers, and our range is y is greater than or equal to negative 1. So from here, I'm going to plug in 3 and 1. So if I choose the 1, I'm going to have 1 squared is 1 minus 8 plus 15. 1 minus 8 is negative 7 plus 15 gives us 8. So that's 1, 8. Which is also going to give us 6 or 7. 1, 2, 3. So 1, 2, 3, 7, 8. I'm going to also use 3. So when x is 3, I'm going to have y is equal to 3 squared, which is 9, minus 8 times 3, which is negative 24, plus 15. The 9 minus 24 gives us negative 15, plus 15 is 0. So that's 3, 0, which would also be 5, 0. So again, we can find those ordered pairs that have x values of 2 and 6, but we already got them for 1 and 7, so we don't need to. For 39, we have f of x is equal to x squared plus 8x plus 12. So our a is 1, our b is 8, and our c is 12. So our axis of symmetry is going to be x is equal to negative 8 over 2 times 1, which is negative 4. Our vertex is going to be y is equal to negative 4 squared, which is 16, plus 8 times negative 4, which is negative 32, plus 12. So the 16 minus 32 is negative 16, plus 12 is negative 4. So that's negative 4, negative 4. We have a y-intercept of 0, 12. So we're going to plot these. Negative 4. Yes, negative 4, negative 4. We have a y-intercept of 12. We have a minimum value here at negative 4. Our domain is all real numbers, and our range is y is greater than or equal to negative 4. So I'm going to choose, let's choose 1. Actually, let's choose 2, negative 2. So it's going to be y is equal to negative 2 squared, which is 4, plus 8 times negative 2, which is negative 16, plus 12. 4 minus 16 is negative 12, plus 12 is 0. So negative 2, 0. Which is also going to give me 1, 2. So negative 6, 0. And then I have negative 8, 12. Again, I'm just getting these by mirroring. I draw my line, and then we're done. For our last one, we are given f of x is equal to x squared plus 9x plus 20. So our a is 1, our b is 9, and our c is 20. So x is equal to negative 9 over 2, which is the same thing as negative 4 and 1/2. our vertex. We're going to plug that in. So y is equal to negative 9 over 2, which is 81 over 4, plus 9 times negative 9 over 2, which is negative 81 over 2, plus 20, which is 20 over 1. So our least common denominator here is going to be 4, so it's going to be 81 over 4 minus 162 over 4 plus 80 over 4. So we are going to have negative 81 plus 80 over 4, so it's negative 1/4. So our vertex is going to be negative 4 1/2, comma, negative 1/4. So negative 4 1/2, negative 1/4 is about here. From there, our y-intercept is the 20, so that's 0, 20. Oops. We have a maximum or minimum. We have a minimum value. That minimum value is 20. And then we have a domain of all real numbers and a range of y is greater than or equal to negative 1/4. All right, so values that we haven't worked with yet. We can use negative 2, we can use 1, we can use 3, we can use negative 4. All right, so I'm going to try negative 3. So when x is equal to negative 3, we have negative 3 squared plus 9 times negative 3 plus 20. Negative 3 squared is 9 minus 27 plus 20 is 9 minus 7, which is 2. So that's negative 3, 2, which is also going to give us negative 6, 2. I'm going to also use negative 2. So when x is negative 2. So we're going to have negative 2 squared plus 9 times negative 2 plus 20. So 4 minus 18 plus 20 is 4 plus 2, which is 6. So negative 2, 6. And also negative 8, 6. So we are going to have the parabola that looks like this.